So hi all. So today in this session we're going to understand what is ISTIO and why do we require ISTIO. Probably in previous session we have already seen. So why do we require ISTIO and what is the benefit of implementing the ISTIO in the Kubernetes deployment process? We all seen, but we haven't seen what is exactly the ISTIO is all about. We just know ISTIO is a tool to implement or they achieve the service mesh concept. We're going to understand in this session. So the agenda will going to cover all these things. That is, we'll understand what is ISTIO in detail and why do we require. And we have already seen what is service discovery and how it is going to work. We'll see again in the scenario based also. And even the canary deployment, as I just mentioned in previous session, that we're going to see in future slides. We're going to see how exactly the canary deployment will work with example also. And also I've been telling that the each pods will contain or the each container is associated with the proxy container or the proxy server, right? So we'll see that also in detail here. Okay, so we'll understand now what is istio. So istio is an open source service mesh that provides a way to control and secure communication between microservices. So as we have know that why do we require service mesh? So we require service mesh to communicate within the microservices. So without any extra hard coded from the developer. So complete care should be taken care by the Kubernetes of the service mesh itself. So it's offering features like traffic management, security, observability, and resilience without requiring changes to the application code. So it's not required to embed additional code to manage all these things like traffic management, security, observability, and resilience. So without requiring the changes to the application code. So Istio is designed to work with the Kubernetes. So although it can also be used with the other platforms too, but it's mainly to achieve service mesh in Kubernetes, they have come up with Istio. So why do we need Istio? We already understood in previous session in the concept of service mesh, right? So here we'll understand again. So by using the Istio tool in the Kubernetes, we can able to manage the traffic. So Istio allows fine-grained control over the how traffic flows between the services. So it will going to define or it will going to say how the packets or the data should be transferred or the moved within the microservice. This includes routing, load balancing, and policy enforcement. That is security. It provides out-of-box security features including mutual TLC for encryption, communication between the authentication and authorization. So between services. So these all services are provided between the services. So if any communication is happening between one service to another service, it should be encrypted and should not be visible to some other one. And can if it is encrypted means anyone can able to access to that microservices? Definitely no. The authentication as well as the authorization should be done. So only after that the person is allowed to access to that resources. Next is observability. So it's to enhance observability by providing the metrics logging and tracing capabilities. So this helps in monitoring the services performance and diagnosing the issues, right? So it's not additionally to embed or link some other applications to monitor my servers, or it's not required to have another thing, that is not required to have another scripting. So the Istio itself provides observability to inside as a built-in. And resilience. Istio helps to build resilience service by implementing the retreats or failover or timeouts and the circuit breaks which can be configured easily. So it will going to analyze itself and it will provide the service. so without any breakages, and decoupling, as we have already know that what it is. So it abstracts the communication layer, allowing the developers to focus on the application logic, so without worrying about service to service communication details. It's not necessary to developer to keep and focus on communicating or linking between the services. It's not required. So complete taken care will be taken care by that one, right? Next is we're going to understand. We just saw why what is ISTIO the tool and how it is going to beneficial in implementing in the Kubernetes, and what are the benefits we're going to gain it from that by using the ISTIO. So we'll understand the models or the components we want to see in ISTIO tool. One among that is service discovery. So service discovery is the process by which a microservice architecture identifies and locates services within the distributed system. So as service discovery is, it's a kind of a process by which the microservice architectures identify and locate the service within the distributed system. So assume that we have multiple nodes. In one of the node or the server, we have that is the login as well as the sign up microservice, which are running in two independent containers, right? So immediately the one container got crashed due to some natural calamities, or the high traffic might be of any issues. Since they are all machines, we cannot expect what exactly and why it is got crashed, right? So automatically the new pods or the new containers got created, right? So how will the end users know that, or the web servers know that the new server is created and I need to make this server available to the end user to access the content? So someone requires to handle those things, right? So what does the service discovery will going to do? It keeps scanning or it keeps analyzing the or monitoring the whole infrastructure or the environment or the distributed system as here mentioned. So it's keep monitoring, and if it finds any new containers or running in the environment, so it will going to analyze and it will going to check and it will store the data of that particular container information. So what the container is doing and for what purpose the container is deployed, like that, so it will map. So the service discovery help us to in communicating within the services, right? In environment where service dynamically change, that is instance being added or removed. I just mentioned it, right, about the containers, like that. So effective service discovery ensures that service can communicate with one another without hard coded address, right? So the key concepts of service discovery. So dynamic registration. So as just I mentioned, right? So when a service instance starts, it registers itself with the service registry. That is, when somebody got admitted to some organization, so themselves they going to introduce in the team, right? Likewise, here also the instance or the server will going to register themselves in the service registry, providing the information such as network, that is the IP address, what is the port which is in running inside, and the meta information is nothing but the whatever the microservice they are. Example, service version. So when a service instance shut down, it deregister itself. So when it is goes down, automatically the IP or the details, whatever the details is associated with that instance or the server or the container, it deassociates itself, right? And service registry. So we see here, right, service registry, a centralized database or the system that keeps track of all the services instance, all service instance. Like, so it's a central node who going to take care of all association and deassociation and the details of all the service. It's something like register book, as the name suggests. So you going to get complete information about the book content, whatever you have inside, right? So it allows other services to query for the available instance of the servers and their current location, and common registers include console, Eureka, and etc. And another one is client side discovery. So we just saw this service discovery as a central one, and even the client should have, right? So because the client should know, right? So what are the microservices or the container which are running around me, and to whom should I contact for that purpose also. In this model, the client, the servers that needs to call another service, right, in response for querying the services registry to find the available instance. The client then makes request directly to the chosen service instance. These approaches require the client to have knowledge on the service registry. Okay, and the server side discovery. In this approach, the client sends requests to the load balancer. So I am sending an login request or product query to the load balancer or the proxy or the sidecar. We have just done, right? That one. In response for querying the service registry, routing request to the appropriate service. So it will going to find in which microservice the login or the cart details or the catalogs are available. It will going to identify in the service registry of the service discovery, and it will redirect to me, that is it will going to redirect my request to that appropriate service or the instance of the microservice. This abstracts the discovery logic away from the client, so we cannot able to see all this logic, right? So when we are accessing the resources or the content over the web, so what we only see, we just provide the details what we want, and we will revert it back with the response, right? Only that much we can able to see. Whatever the backend things is going to happen, we won't be able to see. So this is what exactly is happening from last few years. So, and if something is running, we should always checks for itself, right? Or else we might chance of losing the data or would be unavailable to the end users. For that, we should ensure checking the health check of the complete service list. Oftenly perform health check to perform ensure that only healthy service instances are available for discovery. If an instance fails a health check, it is removed from the registry. So for example, if some registry or the some containers got crashed, so it's not required to be in the registry itself. I can deassociate it because it's nowhere going to useful for me in future functionality or the request. So we're going to deassociate it so that we can have more space, right? So we're going to understand by using the scenario based example. So considering the microservice based e-commerce application with the service like product service, card service, and the order service, same example as we have come across in the service mesh, like service registry. So when the product service starts, it's registering itself with the service registry with its IP and the port address. So we'll assume that the product service container got launched and it's working well and good. So it intends go to service discovery and says that I am server, that is I am product server service microservice which I am actively running to provide a service, and this is my address where I can be available for all time to your service. Like that it will say, and it will register itself to the service discovery of service registry, right? Next, what exactly is going to happen in service discovery? We'll understand. Client side. The card service require, that is service queries the service registry to find the current instance of the product service when it needs to fetch the product details. So what they are in client side, what in that is in my side, I going to find some products. I wanted to require some product details. So I will send a request. So from there, where it goes to server side. Alternatively, the card service could send a request to the load balancer. That is, whatever the request I am making, it will be sent to load balancer, which queries the registry. So it will going to query, or it will going to ask for service registry regarding, so this person has requested for this content, could you please check where it is available, in which container or which instance it is available. So once it is located, next the router will take care of that to navigate to that particular instance through the shortest path and with the all securities things. So next routes the request to an available instance of the product service. So where that my product details or the content is available, it is going to redirect to that particular service. Obviously, the health check will be done. Okay. So we just understood that what is ISTIO, why do we require ISTIO, and what are the benefits of ISTIO. And another one is service discovery. So how exactly uh, the communication between the different services or the microservices will happen based on the service discovery, since they are all registered to service registry. Through that they're going to communicate with each other, right? And another concept is what is canary deployment. So canary deployment is a software releases, so it's a strategy to release your software to end users that allows new version of an application to be deployed to the small subset of users before rolling out to the entire user base. So we have already come across or we've been to used to meta version, beta version of the applications, right? Exactly, those are deployed using the canary model of deployment. So how exactly it is going to work? Let me just brief you something. So for example, initially the WhatsApp got launched, right? So there we do not have much feature. So as they when they progress further, today we have the payment also, that is UPI is integrated to WhatsApp and we can share multiple medias irrespective of size as the with terms and conditions, right? So we can able to share. So before that we could not able to share it, right? So assume that, so before rolling out to all users who are all using the WhatsApp, they're going to release the update for very few users, that is the beta version of the applications. So why do they deploy the beta version? So they wanted to test their application, so whether they are able to give proper service, so whatever the features they are embedded to that, whether they all can able to use that without any issues or the bugs, or somebody is facing something like something issues so while using that version. So everything will be taken feedback from the beta users, and based on that review they going to have, or the developers are going to fix those issues. And probably you might ask, so how will the know that only the beta version will go, that is some few people will going to bet the beta version rest or not? So that is where the concept of canary deployment will come. So for example, we have a two server, and on top of that they will be having the, that is ISTIO, the canary deployment model are placed. So what exactly the canary deployment model will going to do is, so it will instruct the traffic management system or the load balancer saying that divert only the 10% of the traffic to my beta version server and rest 90% to the regular server or the meta server. Okay, so on those cases, so whoever are already registered, they see for in registry, and they going to get the beta updates like that. Okay, so versions rolling out before the user base. The name canary comes from the phrases canary in the coal mine, which refers to the practice of using the canaries to detect hazardous conditions. In this context, it means that using a small group to test the new versions of any issues before a full scale rollout. Okay, so we're going to understand, so what are the benefits of using the canary deployment model. So incremental rollout, a new version of the application is gradually released to the small percentage of user, as I just mentioned. If no significant issues are detected, then the deployment can be continued to large audience. So as I just mentioned, right, the beta or server will going to have only the 10% of the traffic among the 100%. Rest 90% will be going to existing server itself. So gradually they going to increase the percentage of traffic to the newer version, and they going to retain the older version server for few days. Once the newer version is well and good to go, they going to deassociate it completely. And monitoring and metrics. So during the canary phases, performance metrics, error rates, and the user feedbacks are closely monitored to identify any potential problems early. When I just explained it, right? Next, rollback mechanism. So if the new version encounters significant issues, it can be rolled back quickly. So anyhow, they are not completely rolled out, right? 100% of the traffic to that new beta version. So they have complete control of both the servers, that is new version as well as the older version. So if they find anything major issues which is affecting the process or which is affecting the primary functionality of the application, immediately they go and update that, divert 100% of the traffic into existing server itself, and no traffic to new instance like that, or the new version of the software. That is the advantage, major advantage we have. And traffic control, just I just explained it how exactly they going to do all those things. So traffic can be routed to the country version using the techniques such as load balancing, feature flags, or routing rules in the service mesh, like ISTIO. In ISTIO only they going to mention all those things. We'll understand using some scenario based concepts. Imagine a pictorial online banking, so fictional online banking application that is updated its transaction process feature. Initial deployment. So initially they have some raw application, right? Initial launch. That is the deployment team creates a new version of the transaction processing service that includes optimization and the new features. In the initial deployment, they have a very basic things. Okay. Using the canary release, the new version is deployed to only 5% of the users, while previous version continues to serve remaining 95% of the user. So this can be managed through the load balancer that routes the percentages of traffic to the new version. Like it will going to monitor. So during the period, the team closely monitor the key performance indicator such as transaction time, error rates as the user feedback. They're going to monitor all these things, and they considered it as seriously, and they're going to rework on the work if they got any feedback from the users, error rate, everything. So till that they're going to make this 100% and they're going to make it zero. Okay, so evaluations. So if the new version performs well without any critical issues, the team can gradually increase the percentages of users accessing the newer version, eventually rolling it to the 100%. So initially they have released only 5% of the traffic among the 100%, right? So gradually they're going to increase. So from 5% they're going to 25% or 30% and 50% gradually increase to 100% like that. They won't completely move on a one go of 100%. So gradually they increase the traffic routing. Rollback. If any major issues are detected, if the beta version did not success as expected, the rollout will come into exist. If any major issues are detected, the team can quickly roll back the changes, ensuring that only small number of users were affected. Fine. And that is all about canary deployment model and the advantages of having the canary deployment model, or the features we won in using the canary deployment model. Another one is NV sidecar proxy. So we'll be using the proxy to communicate with service to service without direct communication to the service, right? A sidecar is designed a pattern used in microservices architecture where a secondary service, that is the sidecar, microservice in microservice architecture, this NV sidecar is the secondary service, that is sidecar, runs alongside a primary service in the same environment. In the same pod itself, they're going to run. This sidecar provides additional capabilities without altering the primary source code. So it is nowhere going to affect the another container or the microservice which is already running. It won't get going to disturb that. So it, on top of that, it will going to have another container called sidecar proxy, that is Envo. So Envo is a open source edge and the service proxy designed for the cloud native applications. It was developed by Lyft and is a key component of the service mesh architecture. Like ISTIO. Envo act as a sidecar proxy, providing the range of features to manage communication between the microservices. So the sidecar proxy is a client-side service discovery thing. Sidecar, like how exactly it is going to work, we'll see. Inside, in service mesh like Istio, Envy is typically deployed as a sidecar proxy along the side each service. So each and every service will have a sidecar proxy along the side. So here's how it works in practical scenario. So deployment. So each microservice in the application is accompanied by the NVO sidecar, right? This means when the application run, it has a two containers. So one is your microservice, another one is your proxy service in the same pod. So we're going to see how it will be like. So traffic interception. So all incoming and outgoing traffics to the microservice is routed through the sidecar proxy. This allows Envoy to handle the task such as implementing security policies, managing traffic routing, collecting metrics and observing it, and controlling plan integration. So Envoy receives the configuration updates from the control plan. That is, we have a right data plan and the control plan. Like that, the control plan will going to send all the configuration to the Envoy, that is ISTIO control plan. So allowing dynamic updates to route rules, security policies. So if I made any changes in communication and accessing the data or making available data to the public or the web, so whatever, I cannot go and instruct each and every containers or the pods saying that it should be updated. So the control plan will going to send a command to data plan like these configurations should be updated like that. So it will going to update on a go. So imagine an e-commerce application with multiple microservices like product cart orders deployed in Kubernetes using Istio as the service mesh. So each microservices as a envoy sidecar proxy. So when a user interacts with this card service, so whenever I try to interact with some products or the, that is, I have some products in the cart, so just I wanted to check out. So how will I going to interact? So the request is first received by the envoy proxy. Then envoy performs security checks. So whether it checks for am an authorized person, do I have a rights to access to these resources, everything will be checked. Thereafter, it routes the request to the appropriate service, that is product service, and then collective metrics. The response from the product service is also routed through Envoy, so which can log the response time and the error rate. So in response to the product service, so it will keep monitoring and it stores the all the logs like whatever the intended request is properly sending back to the user, it will cross verify. If there is any issues, it will keep that error and it will notify the certain team saying that there is a delay or the error in responding to the requested one, like that. Okay, so that is the about envoy invoke sidecar proxy, how it is going to work. So we're going to understand complete scenario based how the ISTIO is implemented in Kubernetes environment. Okay, so application overview. Obviously, we will be having it three different microservice. One is product service, one is card service, and one is order service. So setting up the environment. So assume you have a Kubernetes cluster ready. We will install Istio. So you have all ready to be things, like you have already installed the Kubernetes, which is running well and good, and you just need to install Istio and deploy your microservices. Okay, next, how do you install? So initially we need to download this Istio, like, okay, and set the path and Istio with the demo profile, like all these things. Okay, so I just downloaded Istio and Istio set profile demo. I will be saying yes. Next is deploy the service. To deploy the service, I should have some namespace or the folder or the like to different things. I should have, right, for Amazon. I should have different namespace for Amazon. I should have different namespace for Flipkart, Mintra, Zomato, Swiggy, like that. So for all e-commerce things, I should have different namespaces. Okay, so we're going to create initially by passing these commands. kubectl is the API kind of things which is going to interact with the AWS, sorry, Kubernetes master. Okay, so next, create namespace like e-commerce. In the name of e-commerce, I will be creating the namespace. Then I will be enabling the Istio injection. So let label the namespace for automatic sidecar injection. That is, whatever the things I going to deploy inside the e-commerce namespace, that should embedded with the Istio injection. That is kubectl label, that is namespace, whatever I have given is e-commerce, then followed by Istio injection should be enabled. On that case, whatever things you're going to deploy inside the e-commerce will have Istio injection. And now we're going to see how exactly you're going to deploy the microservice. Okay, so initially I will define my pod, what is the version of the pod, and kind is deployment since I want more containers. And I give the details to my pod as my pod name should be of product, where it should create in the namespace e-commerce. And what is the specification or what my pod should contain is of two container which matches the label, that is product, and template is same as that, and the container. So I have given, that is a, I have mentioned the replica as two, right, but here I have given only one container. So that means that the same container will be created twice. Okay, so containers, my container name will be like this, and image, so whatever the image or the application packaged container application which you are already in the Docker app, that should be given here path, and in what port number your microservice is going to get access to the outside with the public IP, that should be mentioned here, that is your container port. So just I have written the code, that is what is my pod name and in which namespace or the work environment it should be created, and how many containers should be there, and in container what should be running. That is what I just mentioned or scripted here. From there I should have load balancer, right? For that I will be using the service in the same file itself by differentiating the 3 hyphen which says YAML file. Okay, so kind is service metadata, again it is referring to the same namespace of product, and specification, that is the port, what is the port you're going to give here is same like that, and the targeted port is nothing but the outside which port you should use to access the information inside this container. Same, you can have same or different you can. Okay, next is selector, that is for what you are creating, so for which microservice you are creating the load balancer. So that is they are going to here mention, that is the selector having the app product. So for that it will going to create the load balancer. So what we did, we just created the pod, along with that we will have few containers inside that. On top of that we merged two containers into single IP address, that is using the concept of load balancing, right? Now it's time to configure or install the ISTIO. Now traffic management. So here I will be managing the traffic in this script. So create a virtual service to manage how traffic flows between the card services and the product service. So like how I have created the script for the product, likewise we will going to have two another scripts with different names and the image as well as the port. Here it has product, now it could be order or the cart, likewise. Okay, so once after creating three different pods along with the container as well as the load balancer for individual things, thereafter we going to create network configuration on top of the namespace. Okay, so here I am mentioning my API version. Look, observe here, my API version is completely different from here to here. Here I am using the istio thing, so I am pulling the details or the libraries. Okay, so my API version, that is networking.istio.io, that is input output of version, that is, this is the traffic management thing I am using. Kind virtual service, so here I'm not using any physical wired things, right? It's completely a virtual service. And the metadata, what metadata I'm giving for cart I am creating here. Okay, then is namespace, so it should be inside the e-commerce things, and followed by host, that is hyphen cart, and what protocol we'll be using, and route, that is how much of percentage the traffic should be redirect to that one container and to another container, like that I will be mentioning here. And the destination, host is cart, and the port number, like that. Okay, and enabling security, for this I will be writing different one. So pre-authentication policy, enforce mutual, that is authentication and authorization should be made right for accessing the content, or else it will no use of deploying the services. Okay, API version here, it's completely different from this. security.istio.io.v1 beta 1. So kind pre authentication, that is peer authentication, meta and default, so they will be using the strict one. Okay, to run all your YAML files, same command will be used, but the name of the file will differ. So this is how you people will, that is we going to deploy our microservices inside the Kubernetes with the implementation of service mesh using istio tool. So this is all about the istio concept and how it is going to help, and what are the benefits of using or adopting the istio during the deployment. Everything is all about this. Thank you.